These are the second half of your notes for Unit 6, Day 6 of Pre-Calculus. So let's scroll back down to where we ended with. So building sine or cosine functions. So we have the middle of the graph first, and then find your amplitude, find your period, and then find the phase shift. So you take bx plus c, where c is going to be your phase shift, and you set that equal to 0. Remember, that's how we figured out how many need to move left or right. And then you solve for c. And once you solve for c, that's going to equal your phase shift. So let's look at an example of this. So building a sine function from a graph or from data points like we did. So we're going to first do this by hand, and then we'll use Desmos to do it. So if we wanted to do this, first step I said was to find the middle of your graph. So the middle of my graph looks to be right here. And then how many did you go up and down from the middle of your graph? Because that would give you your amplitude. So the middle of my graph looks to be at 50. So it looks like the entire graph shifted up 50. So it looks like my vertical shift is plus 50. The amplitude from the middle of my graph, it looks like the graph moved up and down 25. So it looks like I have an amplitude of 25. And then my period, it looks like my graph starts at 1 and ends at 12, right? So this looks like the start of my graph and the finish of my graph, going from the lowest point then back to the lowest point. So it looks like the period of my graph is 11. So remember, you set your period equal to 2 pi over b in order to find b. So 11b is going to equal 2 pi, and then divide both sides by 11, and b is going to be 2 pi over 11. So far in my formula, I should have, if I do with the sine graph, I would have y equals 25 sine, and then 2 pi over 11b, and then I don't know what that next part is because that's the phase shift, and then plus 50. So that's what my equation of my graph looks like so far. And now for my sine graph, remember sine needs to start at 0 and then go up and then come back down. So it looks like that's how far over my graph moved. So where did my graph shift over to? It shifted over to 4 if this was a sine graph. So my horizontal shift, it shifted over positive 4. So if I take 2 pi over 11 x and then minus 4, I should get 0. Nope, plus 4, sorry. So it's y equals a sine bx plus c and then plus d. So if I do this, I'm going to, and then up here we should solve for x, sorry, not c. So we're going to solve for x. And that's going to give me what that phase shift should be, or what that c should be. Actually, no. If we plug, my x value is 4, and then plus c should equal 0. There we go. So if I solve for c now, c is going to equal negative 44 pi. Sorry. C is going to equal, negative c is going to equal 8 pi over 11, or c is going to equal negative 8 pi over 11. So we should have minus 8 pi over 11. And so now if I go to graph this on Desmos, I should get the same points that I wanted. So if I do y equals 25 and then sine, and then we have 2 pi divided by 11, and then x, and then minus 8 pi divided by 11, and then end those parentheses, and then plus 50, my point should follow somewhere near where those points followed on that graph. So 1.2525, I had 125, and then that high one should be at about 6.7575, and then that low one, 12.2525. We were close. So notice these dots didn't fall perfectly on a perfect sine graph, but this is a pretty close estimate of what that graph should be. So let's go through the steps again. First, you should find the middle of your graph. So we found the middle of our graph right here, which was at 50, and then how far up and how far down you go gave you your amplitude. So we went up 50, it had an amplitude of 25. The period was how long it took to complete one cycle. So it started at 1 and ended at 12, so my period was 11. So you set 11 equal to 2 pi over b. And if you solve, you get b is equal to 2 pi over 11. And so that's what goes right here, 2 pi over 11. And then to find the horizontal shift, I moved to the right 4. So we have bx plus c equals 0. So the b value was 2 pi over 11. The x value, we started at 4, so I'm going to plug in 4 for x, and then plus c equals 0. That allows us to solve for c, the phase shift. So subtract the c and then divide by -1, and your phase shift was -8 pi over 11, or that's what the c value that you would plug in to find that phase shift. And so that's going to plug in right there, and then that is your equation. If you wanted to do this with a cosine graph instead of a sine graph, so let's look back at that. So if we did it with a cosine graph instead of a sine graph, it's going to be a very similar process. So we still find the middle of the graph. The middle of the graph is still 50. We're still going up 25 and down 25. But now my cosine graph is going to start up right here. And so my phase shift, if we come down, it looks like that x value, instead of being +4, would be +7. So you would take 2 pi over 11 and then times 7 plus c equals 0. So we get 14 pi over 11 equals -c. So the c in this case would be -14 pi over 11. And so my cosine graph would be y equals 25 cosine of 2 pi over 11x and then minus 14 pi over 11 plus 50. That would be one way of writing the cosine graph. I could have also done it where I started at this point right here. And if you start at that point right there, notice that would be my cosine graph. It got reflected. So if I wanted to start right there, I would have y equals -25 cosine. The period didn't change, so 2 pi over 11x. We still have plus 50. But then notice, if I start right there, I'm starting 1 over. So you would take 2 pi over 11 times 1 plus c equals 0. And so in this case, c would equal -2 pi over 11. So we would have -2 pi over 11. And so if I went to Desmos and I graphed both of those, so if we had y equals, and let's just do the 25, and then we do cosine, and then we do 2 pi divided by 11, and then x, and then, oops, x needs to be in the numerator, x, and then minus 14 pi divided by 11, and then plus 50, what do you think is going to happen? It matches up perfectly with that original green function. So if I took the purple away, you'd have the green. If you put the green back on, they're the exact same function, which makes sense because sine and cosine are the same waves, just shifted. So if I do that bottom one where y is equal to -25, and then we do cosine, and then we do 2 pi divided by 11, and then go over x, and then minus 2 pi divided by 11, and then plus 50, it's going to be the exact same graph again. So all three of those graphs lay perfectly on top of each other. So all three of these functions end up graphing the exact same wave. So you've got multiple answers depending on where you want to start from. All right. So let's go ahead and let Desmos do all of the heavy lifting for us. So let's go on Desmos and we will enter that data in a table and see how close our function is to what Desmos should say it should be. So we have our month for X. So we have 1 for January, 2 for February, and then we're going to go all the way to December. So we'll have 12 months. And then we're going to enter in our Y values. So 30.7. 32.5, 40.4, 47.4, 57.1, 67.4, 74.2, 72.5, 63.4, 50.9, 38.3, and 30.0. All right, so we'll put the little magnifying glass, And so there is the data points on Desmos. And so now, just like we did before, we're going to do a sine function of best fit. So our keystrokes to do a sine function of best fit, we're going to do y1, and then we're going to do our little approximate symbol like we normally do, and then it's going to be a, and then we're going to do sine, so go to the sine function, and then it'll be b, and then x1, and then plus c, and then end the parentheses, and then plus d. And there you go. So their function that they're saying is the sine function of best fit would be y equals 21.5334, and then the sine of b, which was 0.561916x, and then minus 2.43985, and then plus 51.7812.